Hello everyone, hope everyone's doing well. We're going to look at section 5.2 in our book, which is solving systems of equations using the substitution method. I do want to do a quick review of what we're even doing when substitution method, like what our goal is, and it's to find a solution to a system of equations. So I'm going to practice how to check to see if your answer is even right in a system once you finally do get your answer. So question 1 says, is this coordinate point 4, 5 a solution to the following system? So what I'm doing is I'm giving you these systems of equations and I'm asking you to solve them with substitution. Well, let's say we got an answer like 4 comma 5. How do we even know if that's right? How do we check that? And this is what we're going to do. There's a couple ways we can do this. First, you have to identify which of those coordinate points is the x value and which one is the y value. So x is 4 and y is 5. So you can go into equation number 1 first off. So let's say equation number 1, and remember x is 4 and y is 5. So I'm going to put in, instead, I'm going to rewrite this equation where x is 4, so it's going to start with 4 plus, and if y is 5, it's going to instead say 4 plus 5, and then equals 9. And you have to think to yourself, is that a true statement? Is 4 plus 5 equal to 9? And it is true. So we know it's true for the first equation. What about the second equation? So you'll go over to equation number 2, and you'll say, well, if x is 4, then you're going to have 3 times x, which is 4, minus 2 times y, which is 5, equals 3. And we're going to have to see, is this true? And it's kind of hard to tell right now, so you have to simplify it a little bit. So let's do 3 times 4 first. That's 12. And then 2 times 5. Remember, we multiply before we subtract, so we'll multiply negative 2 times 5, which is negative 10. And is that equal to 3? 12 minus 10 equal to 3, so this is a no. This is not true. So what does that mean? What does all that information mean? It's true for the first equation, but not true for the second equation. That means that 4 comma 5 is not a solution to the system. So a solution to a system is when a coordinate point satisfies both equations. So what this looks like on a graph, and there's a way to check it on the graph, is the first equation, equation number 1, x plus y equals 9. So that graphs some sort of line that probably looks like this. So let's say that's equation number 1 on a graph if we were to graph it. I'm just doing a quick sketch right now. And then let's say we graphed equation number 2. So equation number 2 probably looks something like this. And here's equation number 2. The solution is the coordinate point that they intersect at. So that would be the solution. And what this problem is saying is 4.5 is not that coordinate point where they intersect. So that's how you check to see if a coordinate point is a solution. You take the coordinate point, substitute it into both equations, and see if it is true for both equations. The next question I want to look at is example 2. So example 2 is an application of systems, and so when we read this problem, it doesn't look like a system of equations, but it actually is. So let's read through this. It says there are no prices on a snack bar menu, but you watch someone order 3 hamburgers and 2 drinks and they are charged $16. Your friend tells you that 1 hamburger costs the same as 2 drinks. Write the system of equations and solve it using substitution to determine the price of each item. We're going to let x represent the cost of hamburgers. We're going to let y represent the cost of drinks. So anytime you read hamburgers, you should be thinking the variable x. Every time you see drinks, you should be thinking the variable y. So this statement right here that says 3 hamburgers, remember x represents hamburgers, so that right there represents 3x. And it says 2 drinks, so when you read 2 drinks where y is drinks, that's going to represent 2y. So if you put the 3 hamburgers and the 2 drinks together, they're charged $16. So we can say that 3x, 3 hamburgers, plus the cost of 2 drinks equals $16. And there is an equation that just looks like our normal system of equation problems, but this now represents the cost of hamburgers and drinks. And then there's another equation in the next sentence. It says your friend tells you that 1 hamburger, remember x is hamburgers, so this is 1x right here, costs the same. Remember the mathematical symbol for same is equals. So 1x equals 2 drinks, and remember y is drinks, so we can represent that by 2y. So 1x equals 2y is the equation in that next sentence. So 1 hamburger is equal to 2 drinks. There you go. There is a system of equations. We don't know the price of the hamburger and drinks, but we can use that system to go ahead and substitute to solve. So what we're going to do is, I'm first going to erase this one. We don't need it because coefficient of 1 is never needed. And we are ready for substitution. Do you see how x is equal to 2y? And the whole goal of substitution is make sure one variable is solved for. So since we have x equals in the second equation, I'm going to label this equation 1 and equation 2. Since equation 2 is solved for x, I'm going to use that for the substitution. So in equation 1, do you see how there's an x right here? There's an x right here. That one is going to be replaced with 2y. And why can we replace x with 2y? Because x is equal to 2y. That's what equation 2 says. Since x is equal to 2y, this x can be replaced with 2y. And that's what I'm going to do. I'm going to write 3 times 2y plus 2y equals 16. So let's rewrite equation number 1 with the substitution of placing 2y right there. So here's our new equation number 1. Says 3 times, instead of x, 2y plus 2y equals 16. Now let's go ahead and simplify this and solve for y. We have 3 times 2y, which is 6y. 3 times 2 is 6, plus 2y equals 16. And then I have y's common, like terms. So 6y plus 2y is 8y. 8y equals 16. And then you're solving for y, so we're going to divide both sides by 8 to get rid of the 8. And y is equal to 16 divided by 8 is 2. So that is the y coordinate of your solution point. So remember, a coordinate point is the solution to a system, and 2 is the y coordinate of that solution point. Now, how do we get the x coordinate? We get the x coordinate by using the other equation. See how we used equation number 1 to solve for y? Well, we're going to use equation number 2 to solve for x. Equation number 2 says x equals 2y. And remember what y is equal to? Y is equal to 2. So we can actually say that x is equal to 2 times y instead is 2. And 2 times 2 is 4. That's the x value of your coordinate point. And there's the solution to this system. So what does that solution mean? Remember what x represents. X represents hamburgers and y represents drinks. So hamburgers are $4, because the x value is the hamburgers. Hamburgers are $4, and drinks are $2, because y represented drinks. So we didn't know the price of them, but we can figure it out with this system of equations. The system solved for the price of both hamburgers and drinks, even though they weren't displayed. All right, so we're going to do a little substitution practice with that. So let's go ahead and look at the next one. There's no context to this one. We're not talking about hamburgers or drinks, but we could have a context to this. This could model some sort of real life situation. So remember, the goal in substitution is you look at equation 1, you look at equation 2, and you decide to yourself, is one of the variables solved for? And in this case, yes, one variable is solved for in equation number 2. Equation number 2 says x equals, and you need x equals to use substitution. So since x equals 3y, we can take 3y and place it right here where this x is in equation number 1. Because x is equal to 3y, that x can be equal to 3y in equation 1. So here's our new equation number 1. Our new equation number 1 is going to be the equation where x is rewritten with 3y. So let's start off. Equation 1 starts off with 2, and then x, which is being replaced with 3y, and then the rest of it is plus 2y equals 8. So there's the equation, and that needs to be simplified. Let's go ahead and simplify that. We have 2 times 3y, which is 6y, plus 2y equals 8. We're going to simplify our like terms. Our 6y plus 2y, that gives us 8y. 6 plus 2 gives us 8, so 6y plus 2y gives us 8y. And then we need to solve for y by getting rid of that 8, so we'll divide to get rid of that 8. And we got 8 divided by 8, which is 1. So the y value of our coordinate point that we're looking for is 1. Then remember, we used equation number 1 to solve for y. We need to use equation number 2 now to solve for x. So equation number 2 says x equals 3y. And remember, y is equal to 1. So we're going to use that information in equation number 2. Since y is equal to 1, I'm replacing y with 1 right there. So it's the exact same equation with y replaced with 1. We have 3 times 1, which is 3. That's what x is equal to. So we have our coordinate point. The x value is 3. The y value is 1. Now remember, there's a couple ways to check your work here. You can substitute this coordinate point into both equations, but I also want you to get comfortable with how to see if that solution 3, 1 is correct by using Desmos. So what I'm going to do is I'm going to, off to the side, I'm going to put that equation into Desmos. So let's go ahead and get a Desmos window going here. Okay, all you have to do to use Desmos to check your answers is to type in the equations exactly how they're written in the problem. So the equation was 2x plus 2y equals 8. So I'm going to go over here in Desmos and I'm going to write 2x plus 2y equals 8. 2x plus 2y equals 8. And it's going to graph a line for you. The other equation, you're going to have to step down in Desmos to the second line and put in the other one. X equals 3y. So you put x equals 3y. And do you see that they intersect? Let me zoom in a little bit. They intersect, won't this let me go? There it is. They intersect right here at that coordinate 3, 1. So that coordinate 3, 1 should perfectly match the answer that we got in our problem. And that's exactly what we got. We got 3, 1 right here. So we know we did it right. We can check all of these in Desmos after we do the work. So let's try another one. What we're going to do for this one is we're going to try question number 6 down here. It says solve the bottom equation for y, then substitute. So question number 6 does not have one of the variables solved for. Notice equation number 1 does not say y equals or x equals. Equation number 2 does not say y equals or x equals. So we need to do a bit of work before we do substitution in the first place. And what I suggested in these notes is that you do the bottom equation and solve it for a variable. Now the variable it's best solved for is x in this case, because all you have to do is add y on both sides to cancel that minus y. So I'm going to cancel the minus y with adding y. That's going to be gone, and notice there's only an x left over on the left side of the equation. So we're going to put that x in equation number 2. So here's a new equation number 2 right here. It's going to say x equals, and remember that's our goal for substitution. You want x equal or y equals. On the right side of the equation you have 3 plus y. So I'm going to write 3 plus y on the right side. Okay, so now we need to rewrite equation number 1. So here's our new equation 1. And remember, we need to rewrite equation 1 because we have x equal to 3 plus y. So I can take that 3 plus y, since it is equal to x, and I'm going to place it into equation 1 where this x is right here. So that x is going to be replaced with 3 plus y. So let's write that. So let's have new equation 1, 3 plus y is the new x. Remember, you always put parentheses around whatever you're substituting. And then equation 1 says plus 3y, so plus 3y equals 11. So there's the new equation 1. So notice the only variable that's in your equation is y. So equation 1 will allow us to solve for y. Okay, let's keep going. So we have like terms we need to simplify. There's no number out here that we need to distribute, so we can actually drop the parentheses. So I'm just going to go back and erase the parentheses. Sometimes you need them and sometimes you don't. In this case, you don't need them, but it's always important to write them because you never know when you're going to need them. So let's see, we have a 3. There's no like terms with 3, but y and 3y combine to 4y. So there's 3 plus 4y equals 11. Then we need to go ahead and subtract 3 to get y by itself. Our goal here right now that we're doing is getting y by itself. So I have 4y equals 8. 11 minus 3 is 8. And then I'm going to get rid of that 4 by dividing by 4. So that requires me to do 8 divided by 4. So that tells me y is equal to 2. So I got part of the the coordinate point that I want. So remember, our answer is going to be a coordinate point, and the y value of the coordinate point is equal to 2 because of that new equation number 1. Help me solve for y after this substitution. So how do we get x? Remember, we used the other equation. So we used equation number 1 to solve for y. Let's use the equation number 2 to solve for x. So x is equal to 3 plus y, but we know what y is. Y is equal to 2 according to our work over here. So I'm going to do 3 plus instead of y, 3 plus 2. So that tells me that x is equal to 3 plus 2 is 5. So there we go. We got the coordinate point 5, 2. And that is our answer. It is not good enough to just stop right here and say, okay, I got my answer, 5, 2. You need to check to make sure it's even right in the first place. So what we're going to do is we're going to open the Desmos tab. Where are you, Desmos? There you are. So we're going to open Desmos. I'm going to get rid of those other equations that I had. And my equation in this problem was, what was it? X plus 3y equals 11. So I need to type that into Desmos. And x minus y equals 3. So let's put those two in. So x plus 3y, make sure you're practicing doing this right now, equals 11, so you know what to do to check. And then x minus y equals 3. And you see that it creates two lines, and the point where they intersect right there is the solution. And where do they intersect? They intersect at 5, 2. Okay, so what did we get for our problem? Look at that. We got 5, 2. So substitution allowed us to get that solution without having to graph anything. So for the last problem in your notes that you're going to turn into me is I would like you to try the one right next to it. Go ahead and try 2x plus y equals 10 and y plus 2 equals x. Go ahead and do the substitution for that. Solve for both x and y on your own. And then at the end, when you get both x and y, check it in Desmos to see if you get it right.